Okay, so we're going to finish 5.5 today. Again, my handwriting is going to be terrible, but we have net change as the integral of rate. Okay, we'll check it later because I forgot. So we're going to focus today on that position, velocity, acceleration relationship. Okay, if you'll remember, the main focus will be that. Okay, now go away. We're going to focus on that relationship, if you remember it, right? So, what in the world are we doing here? Okay. We're going to focus on two different situations here. The first one will be the integral from some time 1 to time 2 of the velocity, which of course is going to be same as that, correct? Okay, now what can you tell me about the result using the fundamental theorem of calculus? The integral of s prime at t. Okay, the fundamental theorem of calculus, right? Integral of a derivative, just evaluate. Okay. So this is what we call displacement. Okay. I'll show you more mathematically what it means, but basically you drive to Denver, back to Glenwood. What's your displacement? It's only like 40 miles, right? Because your displacement is from here to Glenwood. Okay, that's what this is giving us. It takes the positives, takes out the negatives. Okay. The other one, glorious timing, is absolute value of velocity function. Okay. This, it's going to be very similar to that. This is our distance traveled. Okay. So I go from here to Denver, back to Glenwood. How many miles have I traveled? Anybody know? 180 plus 140 is about 320. Okay. And I only know that because I drove it like a billion times a long time ago. Okay. So know the difference between displacement and distance traveled. Okay. All right. Let's look at a problem. So a particle. So you're going to see particle motion problems a lot. Has velocity t cubed minus 10t squared plus 24t meters per second. Okay. We'll try to correct that. So if I have this particle from time 0 to 6, okay, let's do the displacement. Over the time 0 to time 6. These are the easier of the two. There's less work involved. Okay, so displacement
that
0, 6.
Oh.
Yes, handwriting.
Sorry.
Not your fault. That still looks like a B. It happens when we have tech issues and we have to improvise things. Ah, there we go. We got a 6 on there now. The bracket's too big now. Okay.
It's fine.
So we have the integral from 0 to 6, and we write the function in. That's 10. We can't blame the technology for the brain issues. This is going to give us displacement. Okay. Just a regular old integral. Now there's a little bit more arithmetic in there because of the exponents and stuff, but who shall I pick on? Kaylee. What's the antiderivative of that function? You got it. Unless somebody disagrees. Okay, good. Okay, we're evaluating from 0 to 6. And fortunately, one of them gives us 0, but we still have 6 to the 4th over 4 minus 10 times 6 cubed over 3 plus 12 times 6 squared. And do you agree that the next one is 0? Yeah. Yes. Right. Take a look for that one, right? 0, 0, and 0. Okay. So what's the other one? 6 to the 4th. Top of your head, Brandon Hatcher. Yeah, I don't either. No, I don't know that one in my head. So,
that one. I was like, yes, that's the right answer.
That one. No, not that one. So there's some others I could bust out, but you end up with 36 meters if you do the math. Okay. So notice meters per second, right, is the velocity. It's a rate. Meters is a position change, the displacement. All right?
I have a question about that real quick. From the homework. In the problem, they were talking about liters, and I got the right number, but in the back of the book it says gallons, and I didn't understand that.
That's probably a slight typo. We'll check it. That's funny. Okay, don't worry about it. If you see something that doesn't jive like that, just let it go and come to class. If you're looking at this function here, this graph from 0 to 6 looks like that. Okay? So what do you notice about the area under this? Positive. And so displacement is actually subtracting, this is getting taken out. Okay, that bottom part is getting taken out. All right? That's what displacement does. Yes. Well, this is not the number for that area. Right? 0 is not the area. This is times 0 to times 6. Okay, the integral automatically takes into account that these are positive and negative signed areas. Okay. Let me show you the distance traveled. Maybe that'll answer your question. Okay. So the distance traveled is the absolute value, and all it does is it makes this a positive area. Okay. The question is, let me redraw that. Okay. So if we're doing distance traveled, we need the absolute value. Okay, how are we going to do that integral? That's the question of the day. It's one more step on top of the last problem. Hunter.
Once you separate it out from interval from 0 to 4 to 46.
Yeah. How do you know it's 4? How do you know that? Because he's cheating. Okay. We need to find this x-intercept. Because that's where it changes to a negative velocity, right? So if you're a calculator available, you put that function in and you calculate a 0, right? If you have a calculator. Okay, but if you don't, where does it equal 0? Take a t out. Beautiful. Okay. And then we can factor. Okay. Okay, you said 12 and 2. Does that work? Because negative, it has to be negative and negative, right? Because this is positive. So that would be negative 14. All right, good thought. All right, so we have 0, 6, and 4, right? So now we know that this is our spot where it changes direction, and we have to take the absolute value of that. Okay. So, am I moving too quickly today? Is that good? Okay, I slow down. Hit the brakes! Just not too hard. My daughter likes to make driving comments. It's funny. She's a backseat driver.
What does she say?
She's not even 5 yet.
What does she say?
Oh, she does. Like if I speed up to pass somebody, sometimes she'll say, Daddy, you're going really fast, slow down! Or, don't do that again, Daddy! Or, you know, still.
Like, trying to direct.
I know, right? It's fun. But, okay, now you've had time to write that down. Okay, so we split our integral up. And subtract. Can anybody tell me why I subtract? Yeah, there you go. Did you hear that? Why do I subtract?
There's negative value from 4 to 6. It would add.
Yeah, it's a negative area, so you're subtracting a negative answer, which gives you a positive, right? So, do we need to go through that whole thing? I mean, it's just two different integrals, okay? And then you subtract them, and you get these are the numbers you get. So you can see there's your negative signed area, right? That would be this one here. That would be your negative signed area, which gives you, negative 20 over 3. So we're subtracting a negative. It ends up 49 1/3 meters, I believe. Okay, so. It helps if you remember velocity is a direction indicator. Okay? Positive means you're going in the positive, but negative means you actually changed direction. So that's what you're looking at here with the graph, the direction change. Okay.
49 and 30. So what you mean for graph?
You can graph it and calculate that 0 if you want. I did not know 4 was the 0. Cheater looked in the book. I just wrote the problem down and I'm not even looking now. So either this is this kind of question right here, this is non-calculator question because that function is not complicated. The only time you're going to get a calculator-friendly function on these problems is if it is like not calculable by hand. Okay, they'll give you like e to the t cosine t sine t times 10 to the t. Okay, and the intent there is for you to plug it in your calculator and do the math. Okay, so, and I'll show you some free responses on that. Yes?
On the actual exam, is the multiple choice calculator?
There's both.
Oh.
You have 28 no calculator questions and 17 calculator questions, and you get like an hour and a half or 2 hours. I can't remember the time periods. Yeah. The calculator section is the more difficult of the two. That's why they only give you 17 of them in the same time period. It's like 50 minutes. All right, so yeah, and then you have, so that's the order. No calculator, multiple choice, calculator, multiple choice. Then you do the calculator free response. It's 2 questions. You have 30 minutes. And then you do the no calculator free response, 4 questions for 60 minutes. If you keep your calculator friendly questions, you can work on them during the no calculator portion of the free response. You just can't use your calculator. Okay, so yeah, that's the format of the test. By the end, your smoke's coming out your ears. Okay. Do you have any questions here? You think you can handle those? Okay, fine. I take that as a yes. Do you want me to write the homework down again? Yeah? Okay. I'm going to give you 10 minutes of freedom. So take care of some business and get some work done. And then I'm going to talk to you about some AP problems. Sure.
I actually have a question. No, that's my question. Yeah. 21 and 25 were. Yeah, 21 I thought I did, and then I got